This is Math 151, and we're in Unit 1, Topic C. We've been looking at how to find limits by looking at a graph, and in this section we're going to look at how to go exactly the opposite direction. Given information about limits, how could we draw the graph? So our goal is to sketch the graph of a function that satisfies all of the conditions that are listed here. All right, so as we look at this list of conditions, the first two are really just telling us about specific points that are on this graph. F of -2 equals -2 says the point -2, -2 is on the graph. Similarly, f of 0 equals -4 says that x equals 0 and y equals 4. So 0, -4 is on the graph. I'm going to go ahead and place those 2 points right away. -2, -2 would be right there. And 0, -4 is a little out of your vision right now. Eventually I'll slide it down, but I'm just marking 0, -4 is all I'm doing right now. All right. The next statement says that the limit as x approaches -2 is equal to -2. So when x gets close to -2, y gets close to -2. Well, that point, -2, -2, we already know to be a point on the graph. So this is saying that we very nicely just approach the point that's already on the graph. We gave this a name. We called this a continuous point. Nothing funny happens here. There's no holes or jumps or asymptotes. This really just tells me my function is going to be continuous at the point -2, -2. All right, what about this one? The limit as x approaches 0 is -3. That one identifies something kind of interesting. When x gets close to 0, y gets close to -3. But I already know the actual y value isn't -3. It's -4. So it must be that this point 0, -3 is going to be a hole in the graph. The graph will get very close to it in the limit, but it'll skip right over it. And instead, the actual point will lie at 0, -4. So I'm going to put that hole in my graph as well. I think you can maybe just barely see this at the bottom of my screen. Right here at 0, -3, there's going to be a little hole in the graph. All right, the other 3 limits over here. First of all, it says as x approaches 2, the limit is infinity. Anytime we have a limit that equals plus or minus infinity, that's always a vertical asymptote. The graph goes, in this case, way, way up towards positive infinity. So we've got a vertical asymptote, specifically at x equals 2. And again, I'm going to go ahead and just sketch that asymptote in as a dotted line on my graph. It's not an actual true part of the graph, it's just a guideline, but it's helpful to have it there. All right, and then here we have as x goes to infinity, the limit is 0, and also as x goes to -infinity, the limit is 0. This is the end behavior, when x goes to plus or minus infinity. And in this case, on both sides, the right and the left, the graph is going to approach 0, y equals 0, or the x-axis. So these are both essentially giving me the same information, but on the 2 sides. There's a horizontal asymptote, at y equals 0 on both the right and the left sides. So once again, I'm going to sketch that in just as a dotted line, just a guideline for when I go to draw my graph later on. There we go. All right, let's finish drawing the graph. I'm going to scoot this up a little bit now so you can see the whole thing. There we are. You can see the extra point 0, -4 that was cut off before. All right, so based on the information I have here, first of all, there's a horizontal asymptote over here on the left, and I know I have to go through this as that continuous point. So just to make things simple, why don't I start just below that horizontal asymptote and draw my graph so I go through that point. I'm going to show here that I approach the asymptote in the end behavior. All right, there are two things going on at x = 0, the hole and the point. Remember, the hole in the graph represents the limit. The graph has to approach the limit. So as I continue drawing my graph, I got to head towards that hole in the graph. Now, the actual value is down here, but I'm approaching the limit at -3. And that was a two-sided limit. So the same thing over on this side. As I come away from here, I'm going to notice that the limit as x approached 2, this vertical asymptote, remember, was positive infinity. So I'm going to go up towards positive infinity as I approach that asymptote. The limit was actually positive infinity on both sides. It was a double-sided limit. So it's up here near positive infinity on the right side as well. And then other than the horizontal asymptote, there's no more information. So I know I need to come down and approach that horizontal asymptote. I want to make a remark about horizontal asymptotes here. I could approach it directly, just come down and kind of stay on top of it, and that would be no problem. But horizontal asymptotes can be crossed. Just to be clear about this, if I wanted to, I could come down here and I could actually cross that horizontal asymptote a couple of times, or 20 times if I really wanted to, as long as I eventually approach the horizontal asymptote. Remember, horizontal asymptotes are end behaviors. The limit said what was happening as x goes to infinity. It doesn't tell us anything about what happens for smaller values of x. So anything could happen in here. We can cross that asymptote all we want, as long as we settle down as we go towards infinity and approach it eventually. Vertical asymptotes are different. You can never cross a vertical asymptote because the function is undefined there. But horizontal asymptotes only refer to end behavior. All right, let's try a couple more like this. In example 2, once again, the first couple of pieces of information are simply points on the graph. -3, 0, and 1, 0. Oops, 1, 0 are both on the graph. So once again, I'm just going to plot those 2 points, -3, 0, and 1, 0. All right, f of -1 is undefined. That doesn't give me enough information yet to draw anything because I don't know why it's undefined. It could be a hole in the graph, it could be a vertical asymptote. We don't know yet. So I'll keep that information, but nothing to draw. All right, the limit as x approaches 1 is 0, and that corresponds exactly with the point 1, 0. So that's telling me that this function is going to be continuous at 1, 0. Nothing weird happens there. And here's the additional information I need to help me interpret what's going on at -1. So these two pieces of information together are going to help me figure this out. As I approach -1, the y value approaches 3. So it approaches a finite limit, a number. And yet the function is actually undefined. This must be a hole in the graph. At the point where x is -1, the y value is trying to be 3. but it's actually undefined. So negative 1, 3. Put in a little hole in the graph, a little puncture. All right, over here on the right, I've got some information about what happens as x approaches negative 3. And again, I'm going to take both of these pieces of information into account as I think about the situation at negative 3. As I approach negative 3 from the left, I approach y equals negative 2. So from the left, we have to approach negative 3, negative 2. But as I approach negative 3 from the right, the y value approaches 0. So from the right, we approach negative 3, 0. Now, if you look at what's going on at negative 3, we already have a solid dot at negative 3, 0. That was an actual point on the graph. So as we approach negative 3, 0 from the right, we're going to approach that solid dot. From the left, we have to approach negative 3, negative 2 down here. And I can't have two solid dots, one above the other. That would violate the vertical line test. Wouldn't be a function anymore. So that one must be an open dot. All right, next one. As x approaches negative infinity, y approaches negative infinity. Essentially, that's saying as we go to the left, we just keep on going down. It's an end behavior, but not an asymptote. And then finally, as x approaches positive infinity, so on the right-hand side, y approaches negative 1. So that one is going to be a horizontal asymptote. At the end on the right-hand side, we have to approach the finite value negative 1. So horizontal asymptote on the right only is y equals negative 1. So I'll sketch that in only on the right-hand side. There's that horizontal asymptote. All right, let me scoot this up a little bit so you can see the whole graph, and let's draw. Coming towards negative 3 from the left, we said we had to approach this open circle at negative 3, negative 2. And we also know the end behavior goes down to the left. So I think I could just kind of do this over here. Down to the left, but the graph gets close to negative 3, negative 2 as I approach from the left. Now as I approach from the right, I get this jump here. I'm going to jump because from the right I have to approach negative 3, 0. And then I'm going to head up here towards that hole in the graph. Okay. The limit at negative 1 is 3, so we have to get close to that. And it's a two-sided limit, so I'm close on the other side as well. And then the next interesting information I have is the fact that the graph has to go through 1, 0. In fact, it's just continuous there. So I'm going to go ahead and come back down and go through 1, 0. The only other thing that's happening here is the horizontal asymptote at negative 1. And again, you can cross it if you want to. You don't have to. I'm just going to cross it once this time. And then show that I come back up and settle down close to negative 1 in the end behavior. Now, of course, there are slight variations in any of these graphs. Perhaps you made this sort of like a maximum. I went up a little bit afterwards. Either way is fine. You could have crossed this horizontal asymptote 12 times if you wanted to, or you could have not crossed it at all. So there are little variations in these graphs that are still correct, as long as they fit the descriptions. All right, we have one more of these. Number 3 doesn't have a whole lot of information in it. we know that f of 0 is undefined. And again, by itself, that's not enough information for me to draw anything. I don't know yet if it's undefined because it's a hole in the graph, or if it's undefined because it's a vertical asymptote. I'm going to figure that out right away, though, because the limit as x approaches 0 from the left and the right is either plus infinity or minus infinity. So I can tell right away, since the limit is going off to one of the infinities, this is undefined because it's a vertical asymptote. Now this information actually tells me quite a bit about the behavior near the vertical asymptote. I'm just going to kind of do a rough sketch up here. As I approach 0 from the left, the limit's got to go up to positive infinity. And as I approach 0 from the right, the limit's got to go down to negative infinity. So I'll fit that in with my main graph when I draw it. But that's what the behavior near the vertical asymptote has to look like. All right. As x goes toward negative infinity, so end behavior, the limit is positive 2. So on the left, we have a horizontal asymptote at 2. And again, I'll draw that only on the left, like so. And then as we go to positive infinity, so the right side, the limit, the horizontal asymptote, is at negative 2. And let me slide this up so you can see more of the graph. On the right, only horizontal asymptote at negative 2. All right, that's all the information we have. Fortunately, it'll be enough to sketch at least a reasonable graph. I know I have to approach this horizontal asymptote on the left, and as I come in towards the vertical asymptote from the left, the graph goes up to positive infinity. So I'm going to keep it simple on this one. I'm just going to go ahead and go straight up. Now again, you could have crossed the horizontal asymptote if you wanted to. I didn't choose to this time. On the right side of the vertical asymptote, I have to start down here, near negative infinity. And then I'll have to come up and approach that horizontal asymptote over here on the right. And again, maybe I'll just keep this one simple and approach it directly, although it could be crossed if you wanted to. And there's a graph that would fit example 3. All right, that brings us to the end of section 1C.